Hello everyone, welcome to this tutorial. My name is Kevin Agina. I am a student in a graduate school in Murang'a University of Technology IT department. My area of interest in research is in software engineering, and I am majoring in software quality measurement and prediction. In this tutorial, I'm going to take you through introduction to fuzzy logic and its applications. Fuzzy logic is simply one of the approaches that can be used to come up with models that offer solutions that cannot be solved using the existing mathematical models. Or the fuzzy logic can as well be used to make prediction to attributes or qualities that cannot be measured directly. For example, the software attributes or determining software quality. Let's look at introduction to fuzzy logic. The word fuzzy simply refers to things that are not clear, things that are vague, or things that are imprecise. Any real-life event or real-life situation, or even a computer-based event, process, or function that is continuously changing cannot always be defined using the existing mathematical models, or even existing Boolean logic of truth or false, meaning that defining such activities in a fuzzy manner is the best way out. Let's take a practical example to explain this analogy. For example, let's say I'm traveling from town A to town C, which is 100 kilometers apart, and I am traveling at 50 kilometers per hour. If I try to employ the use of existing mathematical model to calculate the time I'll take from town A to town B, it will give me speed over distance over speed, which is 100 kilometers over 50 kilometers per hour. And that model will return that I'll take 2 hours from town A to town B. However, traveling from town A to town B is one of the continuously changing events. And along the way, I might encounter jam. I might encounter other factors like maybe mechanical breakdown of the vehicle I'm traveling in. And now, sometime maybe 20 to 30 minutes will be lost along the way. Then now, I'll not be able to get to the destination at exactly 2 hours. So you'll find that such existing mathematical model will only predict the 2 hours. It won't take into account the lost time, maybe due to jam or due to other mechanical issues. The best solution here is to use fuzzy model. Fuzzy logic model will give you a range of time. For example, the arrival time, you can be able to define arrival time in terms of range. Maybe you can say you will arrive in 2 to 3 hours. So it means in case you encounter jam or you encounter mechanical breakdown for 20 to 30 minutes, you will still be within 2 to 3 hours that the fuzzy logic will be able to define. Then you'll find that most of our real-life events are continuously changing, meaning that fuzzy logic offers better solution to most of our real-life situations than the existing models. Let's take another example. For example, the nation is reporting 100 cases of coronavirus daily. If we try to apply the existing mathematical formula and say what will be the prediction, or what will be the cases in the next 10 days if you are reporting 100 cases daily. The mathematical model will tell you in the next 10 days, if you are reporting 100 cases daily, we will have 1,000 cases. But that might not be the case, because within the 10 days, maybe the nation will be suffering from the test speed, or the capacity of testing will have gone higher or will have reduced. So the number will not be precisely 1,000 in the next 10 days. So if you use fuzzy logic, we will be able to model the number and get a better prediction, a better range, other than having the precise range. So you'll find that fuzzy logic can be used to model such curve, can be used to model such coronavirus cases maybe in the next 10 days and give a better solution than the existing mathematical models. Logic, the aspect of logic has been with us for quite some time. Historically, a lot of logics have been proposed. e.g. the traditional logic or the classical logic of Aristotle. This is the law of bivalence state. It states that every event has got two possible scenarios, true or false. There's no possibility for middle. Then Jan started to appreciate that there might be the middle aspect, and he came up with a three-valued logic that contained true, false, and possible. Then finally, in 1965, the aspect of fuzzy logic came into limelight by a scholar by the name Lofty Zade. Zade published the paper that explained that fuzzy logic is one of the logics that embraces the traditional or the Boolean logic, but it seems as the superset. Other than having the true or false or the 1 or 0, it takes the range in between. And for that matter, Lofty is called the father of logic because he's the one who initiated the aspect of fuzzy logic. And he explained that a fuzzy logic is like a superset of the Boolean logic. So fuzzy logic is seen as the superset of the Boolean logic as seen in the figure below. It contains some rules that will take into account, for example, the example we've given, that the corona cases in the next 10 days, if we have 100 cases daily in the next 10 days, what might be the cases. To model such scenario, it takes some rules, maybe like the testing capacity, the contact tracing capacity. So those rules are used to model and come up with a multi-valued logic that tell us some varied number of the degree of truism, whether we will get the 100 or for the next 10 days or something like that. Unlike Boolean, that will give us exactly, like, for example, if we are getting 100 cases in the next 10 days, Boolean will give us the precise or the crisp value that we'll get 10 days for the next 10 days, resulting to a model of 1,000 cases of corona in the next 10 days, which might not be the case. So in the figure, you will find that the Boolean give us the crisp value. Maybe this is the at the middle is point A, and maybe this is the day 1. Now in day 10, it will give you the crisp value of 1,000 cases. But you'll find that if you're using fuzzy will enable you, if you're starting from day 1, you can get maybe some range. There's a range that you can get due to the rules that we've talked about, the cases that we've talked about, that can vary in between. For example, the testing capacity, the contact tracing capacity, and even other factors. So it means it is not giving, fuzzy logic will not give you exact value that you will land. It gives you some range. It tells you that real life scenarios has got that gray area. Let's get another scenario to demonstrate the aspect of fuzzy logic. Fuzzy logic is always seen to embrace human decision-making methodology, though it deals with factors or values that are imprecise. For example, we are saying that in the next 10 days, we don't know how many number of corona cases we will be having. So we don't have that precise value. We don't have that exact information. We have the vague information. We are saying maybe in the next 10 days we'll be having 100 cases of coronavirus or something like that, but we don't have that precise value. So to come up with a good model that can help us to determine the number of cases in the next 10 days using fuzzy logic is the best model compared to other traditional or existing model, because it will help us to oversimplify. For example, if you are having the number of test capacities, the number of health workers, the number of contact tracing guys on the ground, it will oversimplify the aspect of how many we will be having, and by oversimplification of that aspect, we'll be able to come up with a precise or a better approach in the terms of the degree of truism to solve a real life problem. Taking another real life problem of a glass of water. if you have a glass of water that can contain 100 ml when full, and this glass of water contains only 30 millimeter of water as shown in this figure, you will find that this is 100 ml glass of water, and this glass of water, when it is full, it is 100, but currently it is 30 ml. It contains 30 ml capacity of water. Then if you look at that glass of water analogically, you will say that we have two analogy to describe the capacity, the current capacity. You can say that it's the glass is either it doesn't have water or it has water. So that's the real scenario on the ground. You can say that glass, it's either it has water or it doesn't have water. But if the result of that, if you are looking, if you are using the Boolean logic, the true or the false, we can say that that glass is half full or half empty. However, if you are using fuzzy logic to apply to solve such problem, we can oversimplify the capacity of the content of the water. And now that the glass can contain up to 100 ml of water, and we have 30 ml of water, we can oversimplify and get the precise value and report that we have 0.3 full or 0.7 empty, which is a better prediction or a better interpretation in the capacity of the current capacity content of the glass of water compared to the Boolean. So we can see fuzzy logic offers a better solution to the real life or the real world problem than the traditional logic. Other application area of fuzzy logic. Fuzzy logic is one of the research area in artificial intelligence, and it has been largely adopted because it has the oversimplification. It is very flexible and it can oversimplify data and even express it in a way that we can better understand. For example, in the scenario shown in the glass of water, we can say we have 0.3 full or 0.7 empty, which is a better, has a natural language interpretation of the scenario on the ground. And due to that, it has been largely adopted. It is being used because also the model, we can train the model. For example, the scenario we gave about the cases, the corona cases, infestation, maybe to model the cases in the next month or 10 days. We can train the model such that if the number, we give it some rules that if the number of cases goes to a particular level and the contact tracing is at a particular level, and even the testing capacities at a given level, then we can predict in the next 5 to 10 days what will be the cases. So we can get a better model to predict such analogy because of its flexibility and the training aspect. Not limited to the following, it has been applied in automobile and other vehicle subsystems, in the creating of the speed control systems like the ABS, the anti-braking system. For example, if you are driving an automatic car, if the car be ahead of you is far away, there's that aspect of pressing the brakes. You will find that using the ABS, the anti-braking system, you won't be able to stop immediately. You will be pressing the pressure you will be applying in the brakes of the vehicle will increase as the distance between the you and the car above you is nearing, such that when you get so close to the car above you, the more the pressure you apply on the brakes. Unlike if you are using Boolean aspects to develop the braking system, it's either you press the brake or you don't press the brake. It's either the car ahead of you is close or not, the 0 and 1s. But if you're using the fuzzy logic, you can give some range. If the vehicle is maybe some meters ahead of you, there's that the pressure you apply on the brakes, and the pressure increases as the distance between the two vehicles nears. Temperature controllers to regulate temperature in air conditioner, refrigerator, and water heater. For example, if you are using water heater, you'll find that when you turn on the water heater, it will not just change from cold to hot or hot to cold, like the 0 to 1 or true or false. It will have some smooth curve coming from cold, not so cold, warm, hot. There will be that smooth curve. That is, such controllers can be designed using fuzzy logic. In camera shooting for autofocus, when you want to take a camera and you want to increase the sharpness of your capture, the fuzzy logic can be used to do that. Home appliances like dish washers and washing machines. For example, if you are using a washing machine and you put your clothes and maybe detergents, the spinning of the washing machine will depend with maybe the amount of dirt in the cloth or something like that. So you will find that fuzzy logic has been used in many areas, not limited to that. Thank you for watching, and kindly subscribe for more videos coming soon. Maybe in the next video I'll be now able to interact with the real modeling. We'll now start have the real modeling, and maybe we'll start modeling how we can do some of this prediction practically. Thank you.